going to put some colour on so I can see exactly where my flow is going. I'm looking for the red surge towards my probe. And I'm going to put my cursor through my red surge and then look at it on CW. So optimise my baseline. Okay, so as we've said before, it's nice to have 2 or 3 waveforms in the display here. I will use my measurement package and now go into the mitral valve. Let's say I was looking to see whether the patient had mitral stenosis, so I might want to measure the pressure half time. So I'd measure from the peak here of that early diastolic wave. I'd go along the slope like this down to the baseline, and it will give me a pressure half time measurement of 94 milliseconds. I might want to look at the mean gradient through this valve, so I can pick off the trace option. And then I will just trace around the whole of the waveform. I'll make sure that I remember that this is going on all the way through diastole. So I've got an A wave here with atrial systole. And that's giving me a mean gradient of under 1, which is lovely. So that's nice and normal. So another thing we can do, which is quite a complicated set of measurements, is work out shunts. So we're looking at the cardiac output on one side of the heart and then comparing it to the other side. We're going to talk about this in detail when we talk about some simple shunts and congenital disease, but I want really to think more about the measurements themselves now. So I'm going back to my parasternal long axis view, and I'm going to want to measure a diameter for my systemic circulation. And I do this in the outflow tract, and we do this in other times as well. We do this looking for aortic stenosis. We'll use it in the continuity equation. I will do this measurement in systole, and I want the valve right open like that. Now the calculations package is pretty useful now. It's going to really guide me as to what I want to do. So I'm going to pick off shunts. It knows I'm in an imaging modality. It's giving me a choice of systemic or pulmonary diameter. So this is my systemic diameter. So I'm just going to measure that there. It's going to want me to do the pulmonary artery diameter, so I'm going to swap round now. I'm going into a parasternal short axis view. Now it's quite difficult to see exactly where that diameter stops and starts, so I typically put on colour to give me some guidance to where the walls are. Okay, so that's giving me a bit of an idea. So I'm going to do this in systole again. Probably going to focus quite carefully on this. So you see I was very careful checking the cycle that I got the walls best. Go back to my calculations package, it will tell me what to do. I'm going to measure this diameter about here and put that into the memory. I now want the Doppler waveforms to go with those. So my systemic one I'm going to do in the apical 5-chamber view. I'm going to use colour to show me where I've got flow acceleration in the outflow tract to make sure I sample in exactly the right place. I will use pulse wave, so around here somewhere. Optimise my signal. You saw me press that button. I was just freezing the 2D signal there because it gives me much better Doppler waveforms. Oh, that's a lovely waveform. So now I'm carrying on with my shunts. It says it wants a systemic VTI, so which I'm now going to give it. So I'm tracing around the edge. I'm making sure I don't include any artifact. I don't want the sort of the hairy bit that you get at the top of a Doppler signal. That's artifactual, so we make sure we get the whole waveform itself. So it's giving me a systemic VTI of 21. So one more thing to do, and that's the VTI in the right-sided circulation, so I can go back to where I was in my parasternal view. I'll put colour on to guide me where to sample. There's a little flash of PR there in the centre of the screen, you can see. Okay, so what I will do is sample as close to where I did the diameter actually as possible, where the colour looks like it's going to yield a useful looking signal. I'll freeze my 2D to it because you see how that improves my Doppler image. It gets rid of all that shatter. And I can hear I'm in the valve. That funny noise is telling me I'm actually in the valve itself. That's better. Yeah, that's different. So that's a nice whew. So that means I was on the signal there. So now I'm just going to measure the VTI in the PA. And again, I'm making sure I go around the edge of the waveform. I don't include any of those little hairy bits. I make sure I go right to the end of systole. It'll give me the VTI. It'll do the calculation for me. And I expect that to be 1 to 1 because I know that we haven't got a shunt here. Okay, now I'm going to move on and look at Simpson's. So this is Simpson's biplane, and we use this for working out volumes of the left ventricle and also the ejection fraction. So for this, I need a really, really beautiful apical 4-chamber view, because what I'm going to be doing is tracing around the endocardium, so it's really important that we get this really well, really crisply. So I'll make sure my image is perfectly set up for this. And I'm optimizing my myocardium here. Okay. And I'll be using my ECG, so again you can see how important it is to have your ECG on, because I want to time this at end diastole. Then I'll make sure the mitral valve is shut, like that. And I'm going to go into the measure calculations, and I'm going to look at volumes this time. And I'm going to look at biplane. It's going to be biplane Simpsons. First thing is the ventricular diastolic volume from the 4-chamber view. So I select that. I usually start down here at the mitral valve on the septal side. I'm tracing around the border between the septum and the blood pool, but I'm making sure that I don't include any papillary muscles. It can be quite difficult to do this. If you can't see 20% of the myocardium, you shouldn't do it. Okay, so that's going to be my diastolic. Then I need to trackball through so that I'm in systole. Again, I'm checking I can see the endocardium. And then pick off that measurement. And I'm going to do exactly the same thing here, and then I'll swap round and do the same in the 2-chamber view. So I know now that I've got to rotate my probe anti-clockwise to bring in the inferior wall. Okay, and I will time it on the QRS as I have before. Start around here, trace around, looking at the border. Then into systole. Now you can see a whacking great papillary muscle there. See that? We don't want to include that. So that's giving us volume, a diastolic volume of 154 mils and an ejection fraction of 49, so say 50. I suspect Kim probably does a bit of sport, which is why he's got a borderline low ejection fraction.